You may have wondered what the buttons sine, cosine, and tangent meant on your calculator. So we're talking about this button right here, sine, this one, cosine, and this one, tangent. And I'm going to teach you that today using right triangle trigonometry. And the one thing that I want you to remember is this mnemonic device, so, ka, toa. And we're going to break that up into three parts, so, ka, toa. And S stands for, the so stands for sine of some angle, so sine of x degrees is equal to opposite side over hypotenuse. The ka, the CAH, stands for cosine of some angle is equal to the adjacent leg over the hypotenuse. And the toa stands for the tangent of some angle is equal to the opposite leg over the adjacent leg. So let's see how that lines up in a triangle. If I have a triangle, and once again these are only right triangles, this is right triangle trigonometry, and that's the right angle there. This is always the hypotenuse, the side opposite the right angle. Now there's two other sides and they're both legs, and it's going to depend upon what angle we're looking at. So if this is my angle, x degrees, from x degrees perspective, this is the opposite side, and this is then the adjacent side. And so let's use these examples to show you. Let's say that this is a special right triangle. Let's say that this is 3 units, this is 4 units, and then this would be 5 units. You can use the Pythagorean theorem to see that that would be a 3 squared plus 4 squared does equal 5 squared. So then we would say that the sine of x degrees, so this is x, is equal to, it says opposite over hypotenuse, so opposite is 3, hypotenuse is 5. We'll talk about what that means in a minute. So right now it's just a ratio. The cosine of x degrees is equal to the adjacent leg, 4, over the hypotenuse, 5. And then the tangent of x degrees is equal to the opposite leg, 3, over the adjacent leg, 4. So you may say, what in the world is he talking about? At this point in time, what you know is that these ratios are, these legs will be in this ratio no matter what. If I made this triangle larger and made it like a 6, 8, 10, notice the ratios would stay the same. If this changed to a 6, an 8, and a 10, this would change to a 6 and a 10, which is still equal to 3/5. This would change to an 8 and a 10, which is still equal to 4/5. This would change to a 6 and an 8, which is still equal to 3/4. So you can see that no matter what the size of the triangle, if the triangles are similar, that ratio will remain the same. Now, people smarter than us have calculated what these ratios are. Now let me look at another triangle. And let's say, well, what happens if I know the angle? Let's say that this is 27 degrees. And you know that this leg here is 6 units. And you don't know this one, and you don't know this one. So you don't know the other leg, or you don't know the hypotenuse. To solve this, you simply say, okay, now I look at this 27 degrees, 6 is opposite, this is adjacent, and this is, of course, the hypotenuse. And so, if I wanted to find the adjacent leg, I would say, well, what has opposite and adjacent in it? I look up here and say, oh, tangent. So I know now that the tangent of 27 degrees is equal to opposite 6 over adjacent x. Well, how would I solve that equation? Well, I would want x to be by itself, so I'd multiply both sides by x and then divide both sides by the tangent of 27 degrees. And now we'll get our calculator out and we'll show you how that works. So I would say 6 divided by tangent, hit the tangent button, 27, close my parentheses, equals. And I've got a big problem here because that doesn't look like it makes sense, negative 1.8, and it doesn't. And that's okay because I want to show you what happened here. We are working with degrees. Your calculator may be in radians. So what you want to do before we do this, we probably should have done this first, but it's good to show you that the mistake that can happen. Go to mode, and you can see that as I come down to the third thing, you see radians here. I really want degrees, so push the arrow button, choose degrees, and then we'll quit that and do this again. So now we can say 6 divided by tangent 27 equals, and that makes a lot more sense. So x is equal to about 11.8 degrees. I'm sorry, not 11.8 degrees, 11.8 units, because that's the number of, that's the length, my mistake. So this 11.8 is this length right here. Now to find y, we'll do something very similar. Move this over so you can see it. So to find y, notice that we know the 6, we want to know the y. So we have opposite, hypotenuse. We will use the sine function. So I'll say that the sine of 27 degrees is equal to opposite, which happens to be 6, over the hypotenuse, which happens to be y. So based on what we did back here, we'll take y is equal to 6 divided by the sine of 27 degrees. So on my calculator, 6 divided by sine 27, close it, enter. And y is equal to about 13.2 units. You could use the Pythagorean theorem to show that 6 squared plus 11.8 squared equals about 13.2 squared. Now, it won't be exactly because we rounded it off, but you can put that in the Pythagorean theorem and kind of check it out. Let's do one more example, and then we'll go back to these first examples. So, remember we're going to write our mnemonic device. So, Toa, and here's our example this time. Let's say now I know that this is 15, and let's say I know this angle up here is 30 degrees. So if that's 30 degrees, once again, this is my, we'll call this x and this y for this. This is my opposite. Now notice it's opposite because it's opposite the 30-degree angle. Everything's in perspective of the 30-degree angle. And this is my adjacent. And so if I wanted to find x first, I'm going to use opposite, and of course this is the hypotenuse. Opposite and hypotenuse, that's sine. So the sine of 30 degrees is equal to x opposite over hypotenuse 15. In this case, since 15 is in the denominator, I could just multiply. So I'm just going to say x is equal to 15 times the sine of 30 degrees. So here we go. 15 times sine 30 equals, and x equals exactly in this case 7.5. So this is equal to 7.5. If I wanted to find y, I know the 15 and I know the y, or I'm trying to find the y, so I use hypotenuse adjacent. That's cosine. Cosine of 30 degrees is equal to the adjacent side y over the hypotenuse 15. So y equals 15 times the cosine of 30 degrees. So let's try that. 15 times cosine 30, close my parentheses, enter. And about 13.0. So 12.99 rounds off to about 13.0. So there I found my y. So it's that easy. That's how you would use the sine, the cosine, and the tangent functions in order to find values of legs if you don't know. Now, let's go back to the original problem that I gave you. So I'm going to pull this back. what did this all mean? We had the sine of x degrees equals 3/5. Well, what does that tell us? The cosine of x degrees equals 4/5. What does that tell us? Well, here's how you solve problems like that. In this case, you don't know the angle. So if you don't know the angle, we'll use the inverse sine. So if I wanted to solve here for x degrees, I would say, well, how do I undo this? X is equal to the inverse sine of 3/5. Well, where is that on my calculator? Well, here it is. If I take second function sine, you see the little sine minus 1, and then go 3 divided by 5, close my parentheses. This will tell me the number of angles. So I get x is about 36.9 degrees. Now you could have done that from the 4/5 perspective. So we could have also said x is equal to the inverse cosine of 4/5. Same thing, second function, cosine, 4 divided by 5 equals, once again, we'll get exactly the same thing, 36.9 degrees about. So should get the same thing for all those angles because they're all equal to, we're looking at the same angle just from different perspectives. We'd get the same thing if you took the inverse tangent of 3/4. So couple of problems that you could have. Here are some examples of problems you could have. We've already looked at a couple like this, but let me just give you two problems. Five, 12, 13. There's a right triangle. And I might want to say, what is this angle? Well, you can use, remember we have SO, CA, TOA. From x's perspective, this is always the hypotenuse. This is adjacent. This is the opposite. And you can use it, since I know all three sides, I could use any one of these, sine, cosine, or tangent. Let's use tangent this time. So if I was going to use tangent, I would use the opposite and adjacent. So the tangent of x degrees is equal to 5 over 12. So x is equal to the inverse tangent of 5 over 12. And I just typed that into my calculator. Second function tangent, 5 divided by 12 equals. And x is about 22.6 degrees. Second type of question I could have, you may see something this easy. Cosine of x degrees equals 0.4125. Find x. Well, that's the same thing we were doing here. It just gives you a decimal. So that just means that x is equal to the inverse cosine of 0.4125. And so I just do that. I say second function cosine, 0.4125 equals, or enter, and x is about 65.6 degrees. And then the last type of question, which we had some of, if I know this angle is 52 degrees, and I know one of the sides, let's say I know this side is 12, and I'd like to find this side and this side. Well, remember that this is still the hypotenuse. It's the side opposite the right angle. From 52 degrees perspective, this is opposite and this is adjacent. And so if I want to find x and I know the opposite, I'll use the tangent that has opposite and adjacent in it. I'll say that the tangent of 52 degrees is equal to 12 over x. So if x is in the denominator, I say x is equal to 12 divided by the tangent of 52 degrees. And so I multiply, or I divide 12 divided by tangent 52, enter, and x is about 9.4. Same thing for y, but now I know that 12 is the opposite and the y is the hypotenuse. So I use opposite hypotenuse, that's sine. Sine of 52 degrees is equal to opposite 12 over hypotenuse y. And so I end up with y is equal to 12 divided by the sine of 52 degrees. Type that in, 12 divided by sine 52 equals, and y is equal to about 15.2. I hope that gives you enough information. There are problems like that on the study guide that you can look at as well, and those problems are done for you by one of the high school teachers, and I put a link for that on your homework as well. So hopefully that helps, and have a good day off.